Welcome. Just math, y'all. Here we are today. We're going to be looking at the graphs of polynomials. Okay, so this should be video number 2. You should have already watched the video on end behavior. Okay, so end behavior, the leading coefficient test. Hopefully you watched that one first. And now we're going to look at some other aspects of graphs of polynomials. Now, the first thing we're going to do is see how zeros affect the graph of the polynomial. Now, we've been learning how to find zeros, okay? And so all this time up to this, we've been learning how to find zeros. And so now what we're going to do is we're just going to transition. So this is just a transition example. This is not something you're going to actually have to do. So we have a polynomial here, x to the third plus 5x squared plus 3x minus 9. And we want to find the zeros. So our potential zeros are positive and negative 1, positive negative 3, or positive negative 9. Those are our possibles. Okay, so we get that list from our factors of 9 over our factors of 1. All right, and then we do synthetic division. We pick one of those and do synthetic division. So I'm going to pick 1 and see if it works. Okay, so 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. 3 plus 6 is 9. And 1 times 9 is 9. And it worked. So 1 is a 0. Okay, so now if we remember, this is an x squared plus 6x plus 9. And we want to solve this. This is, a 1x squared plus 6x plus 9. And we want to solve this. Well, this is a factorable quadratic. I can solve it. It's factorable. Multiply to give me 9 and add to give me 6. Well, that's 3 and 3. And so we have x plus 3 equals 0, and we have x plus 3 equals 0 again. Wait a minute, that's the same thing. So I have x equals negative 3 and x equals negative 3. Okay, this is a third degree, so I was expecting 3 zeros, but this is the first time I've noticed that we have the same 0 that occurs twice. Okay, so x plus 3 occurs twice in our factored form. So let's talk about the factored form. Okay, I'm going to skip that part. This polynomial can be factored into x minus 1, x minus negative 3, x minus a negative 3 turns into a plus 3. That's the factored form. This polynomial is completely factored here. If you multiply that all out, you'll get x to the third plus 5x squared plus 3x plus minus 9. Okay, and this can also be written as x minus 1 times x plus 3 to the second power. Okay, that's the factored form. All right, so notice that x plus 3 occurs twice. So we say that negative 3 is a 0 with multiplicity of 2. Okay, so this is a definition. Another way we talk about when we have a 0 that is repetitive, we say it has multiplicity. If it repeats twice, it's multiplicity of 2. If it repeats 3 times, multiplicity of 3. If it only repeats once, it's multiplicity of 1. Okay, so this is transition. You don't have any problems like this, but we've got to learn how to look at the factored form, because that's what we're going to have our problems are going to be in the factored form. So let's look at the graph of this particular one. Okay, so all right, so here's our graphs, all right, and there's rules when it comes to zeros and their graphs. Okay, so here are the rules. A 0 with odd multiplicity crosses the x-axis, and a 0 with even multiplicity touches and turns around. abbreviated T and TA, touches and turns around. So the multiplicity tells us what it's going to do with our graph. So here's our problem that we looked at. Okay, and we're going to graph this. All right, first of all, we look at our end behavior. Our leading coefficient tells us that it's a positive third degree, and so it's going to fall left and rise right. Okay, so it's going to fall to the left and rise to the right. All right, and then our zeros are -3 and 1. So here's -3, here's +1, and our y-intercept is -9. Okay, so from this piece of information and this odd and even thing, we're going to be able to sketch this graph. Okay, so 0, -3 has multiplicity 2. Okay, so the -3 is even. So it's going to touch and turn around. So when I go up this way, I'm going to touch it and turn around. And then the 1 has multiplicity of 1 because it only shows up once. All right, and so I'm going to go up and then bam. So this is kind of what our graph looks like. So we look at the zeros and we can determine kind of what it looks like. Right here, we know from this that this has to be x -3, x -3, and from this, minus -3, and that just goes straight through, so that's x -1. It's always x minus the 0. Okay, so get your rule written down. We're going to piggyback off of this a little bit. Okay, so here we go. Now our homework. We have our polynomials in factored form. We don't have to factor them, thank goodness. We don't have to find the zeros. Well, we kind of do, but they're really easy. All right, and I've done it this way intentionally. But you need to know what the zeros are from the factored form. You're also going to have to learn how to figure out the degree from the factored form and the leading coefficient from the factored form. So let's look at this first one. Okay, so this first one, we're going to look at the zeros. So we have the factors, and each one of our factors represents a 0. Okay, so we have x -1, and that's raised to the second power. So that means x is equal to 1, but it's raised to the second power, so this one's going to have multiplicity of 2. We have x +1, so that would give me x equal -1. And there's only technically one of those, so that's multiplicity of 1. And x -3 equals 0, so that's x equal 3. And so this is multiplicity of 1. So what about our graphs? Okay, so we have the zeros. We have 1, and it's a multiplicity of 2, which is even. So this is going to touch and turn around. We have -1. It's odd, so it's going to cross. And we have 3, which is a multiplicity that is odd, and so it's also going to cross. That's number 1. Let's look at another one. All right, so now this one, we have a -x² equals 0, x + 8 equals 0, and x² - 1 equals 0. Okay, so now the first one, if I set it equal to 0, square root, divide by negative, square root, we're just going to get x equals 0. This one's going to give me x equal -8. Okay, now this one is multiplicity 2. That's even. This is going to touch and turn around. This one is multiplicity 1. There's one factor, therefore we have a multiplicity of 1. There's 2 of these, therefore we have a multiplicity of 2. This is crosses. Now this one. This is kind of tricky. So if you remember factoring, this can factor some more. X squared equals 1. Square root both sides. X is positive and negative 1. Those are 2 zeros. X equals positive 1. X equals negative 1. Okay. If you'll remember, x squared minus 1 is factorable to x minus 1, x plus 1. So each one of these has one factor. Multiplicity of 1, so that's odd, and that's crossing. This one's multiplicity of 1, it's odd, and it's crossing. Okay? All right, so 0 touches and turns around. Negative 8 crosses, 1 crosses, negative 1 crosses. Those are our zeros based on our factors. And those are what the multiplicity tells us on those. Okay, let's look at another one. All right. Now, this one is number 23 on our homework. Okay, and so it's different. It asks for a little bit different things. So let's look through these and see how we want to do these. Okay. First thing it wants to know is, what is the end behavior? Well, to do the end behavior, if you remember from the previous video, we have to do the degree and we have to look at the positive or negative. Okay, so now the degree of this one, if we add all of those up right there, that's going to give us the degree. So this is a degree 6 because 2, 3, and 1 add up to give me 6. So this is degree 6. Now, notice there is no negative. All your x's are positive. They're all positive. So this is going to be a positive. So this is a positive even degree. So it's going to rise on both sides. It's going to rise left and right. Okay, rises left and right. All right, so now the intercepts, these are the zeros. Now, I'm not going to solve for each one, but for the plain x, that gives me an answer of 0. The x minus 4, that's going to be a positive 4. And the x plus 3 is going to give me a negative 3. So those are my zeros. Okay, so now, crosses. Which one of these zeros cross? Well, remember, crosses at the odd multiplicity. Okay, so now let's look. This one is odd. This one is odd. The power is odd. The multiplicity goes with the power on the factor, if you hadn't picked that up on that. So 4 and negative 3 have crossing. Okay, and then for touching and turn around, that's the one that's even, and that's 0. All right. Now, the y-intercept. Well, since it's not in regular standard form, we can't just look at it and find the y-intercept. Okay? We can't just look at it and find the y-intercept. So what we're going to have to do is we're going to actually have to plug in 0 to get the y-intercept. So if I plug in 0, I'm going to get 0 squared, 0 minus 4 to the third, 0 plus 3. And that's going to give me 0 times negative 64 times 3. Well, you know 0 times anything is 0. So my y-intercept is at 0. Okay. And now we're going to graph. Right now, fortunately, the graphs on number 23 is multiple choice. Right, so the first thing we know is that it's a positive even degree, rises left and right. So the left right is going to go straight up, and the right's going to go straight up. What else do we know? Okay, we know our zeros. Our zeros are 0 and 4 and -3. Okay, all right. What else do we know? We know that our graph crosses at 4 and -3. So it's going to come and it's going to cross at -3. And then 0 comes next. And so it's going to touch and turn around at 0. And it's going to cross at +4. So when we do our multiple choice, we're going to look for something that's similar to this. Look for the end behavior. Look for the right numbers crossing. And looking for touch and turn around here. And you should be able to find the answer from your multiple choice. Okay. Last little part, we have numbers 28. I know this video is long, but this is just keeping me from having to do more than one video. So that's what we're going to do here. Okay, so here we have number 28. All right, so now this one gives us a graph, and it wants us to make up some stuff from the graph. So first of all, this is our graph, and it says list the zeros whose multiplicity is even. So if we look really close, we have a 0 here at -3. We have another 0 here at +2, and we have another 0 here at 4. Okay, so now remember, even is touch and turn around. So when we look at our graph, this one is touching and turning around. This one's going through. It's going through kind of funny. We're going to talk about that in a second. And this one's going through. But this one's touch and turn around. Okay, so the 0 whose multiplicity is even is -3. This one's crossing and this one's crossing. So that's odd. And so the zeros whose multiplicity is odd are going to be 2 and 4. Okay, so now here's the strange part that we haven't done yet. It says write the equation, and it goes into details, but basically it says write the equation. It says make the degree small as possible. Remember, each one of these zeros represents a factor. So -3 would be x minus -3. Well, that turns into x plus 3, right? And it has to have an even power on it. It has to have an even power on it. Well, the smallest even number would be 2. So we're going to put a 2 on it. All right, now, the next 2 is where it's different. Okay, we have x minus 2, and we're going to have x minus 4. Now, I told you, look at the difference here. There is this flattening occurring here. All right, so this is for higher powers, higher odd powers. When it flattens, it's higher. Now, this one just goes straight through. This is going to be a power of 1. So there's going to be a power of 1 on the x minus 4. But for the 2, since it's got this little flattening going on, the next higher odd power is going to be 3. We're going to make that one a 3, okay, because of the flattening. All right, and then the last question is, what is the y-intercept? Well, that's pretty easy. We come in here, that's +3. Okay, so hopefully this helps. Don't think I have anything else. Nope, that's something else. That's the end of this one. I know it's kind of a long video, but focus on it. Watch it more than once. Get your rules down. Practice, practice, practice. Because you know what? It's just math, y'all. And you can learn it. You can. Just keep trying because it's just math.